Hey guys, and welcome back to the weekly programming problem. Now today's problem is the Tower of Hanoi problem. Now it's a very famous problem typically in mathematics, but has a really nice recursive solution to it in computing. So that's what we're going to be doing today. Now essentially the problem, if you're not familiar with it, is you're given kind of almost like a toy that looks like this. And what you have to do is you have to move n disks from a given pole to another pole using an intermediate pole. So if we say that this pole is A, B, C, we need to move all of the disks from pole A to say pole C, and we can use pole B to do that. So the only real rule with this is that you cannot place a larger disk on a smaller disk at any point during the game. So I can't, for example, place this disk here and then do that. That won't work. You can see that that's giving me an issue, okay? That's really the only rule to this problem. So how can we solve this, and what is the solution to it in computing, essentially? And what we want as a solution is what moves we should do to go from one pole to the next given n disks. That's what we want for any n, right? So let's start by just figuring out the solution to 3 disks, seeing how we did that, and then moving up and eventually moving into a actual programmed solution in Python. So what I'm going to start by doing is moving this disk, so disk 1, we're going to call it. So we'll start with disk 1, the second one will be disk 2, the third one will be disk 3, and then all the way to n. In this case, it's only 3 disks. So we'll move disk 1 to pole C, we'll move disk 2 to pole B, disk 1 will go back to pole B, and then we will finally move disk 3 to pole C, and we will do the following. And you can see that we have we have found a solution and we have completed this. That was pretty straightforward, and I think most of you can probably comprehend how that worked. Now, let's think about how we move a disk to a pole. And I know this is going to seem really trivial, but this is going to play a very important part into moving 4 disks to the next pole and to our solution. So when we move a disk to a given pole, what we do is we just take that disk and we move it there, right? We know how to do that. So for one disk, if we need to go from pole A to pole C, if it's only one disk, all we do is just move it from pole A to pole C. That's pretty straightforward. If we have 2 disks, what do? Well, what we need to do is we need to move our, our first disk onto the intermediate pole, and we need to move our second disk onto the final pole, and then we move our disk that is on the intermediate pole onto the final pole, or the ending pole. And that's how you do it for 2. Now for 3, this is a very similar solution. What we do is we say, okay, let's pretend that we only have, and let me bring up my drawing tab here. Let's pretend that we only have 2 disks. Okay, so let's say that this is 1 disk. Well, what do we need to do? Well, we need to move this disk to this pole, and then we need to move this disk to this pole, and then from here it needs to go back onto here. And that's how that works. Makes perfect sense, right? That's what we did for 2 disks. So it's the exact same thing with 3. We'll just pretend that in this case we need to move these 2 disks. So we move the first disk to the intermediate pole, the bottom disk goes to the end pole, and then the intermediate pole disk go back to the end pole. That's how it works for 2 disks. So let's now try to do that with 3. So if we need to move these 2 disks now to here, right? That's our task. So our first task is to do that. Our second one's to move this here. So our first task is to move the 2 disks to the middle pole. How do we do that? Well, we know how to move 2 disks to a given pole. What we do is we take the top disk and we put it on the intermediate pole, which in this case will be this one because this is not the destination pole. And then we'll take the bottom disk, we'll put it on the pole that we need to go to, and then we'll take that disk that's on the intermediate pole and we'll put it back onto the final pole. And that's how that works for 2 disks. So if we're given 3 disks, we can use the fact that we know how to move 2 disks to move 3. So that's exactly what we do, right? So now we'll break it down one more time. We say, okay, well, we start and we're going to say, okay, let's shrink this down to 2 disks now. So n minus 1 disks, right? And let's move these 2 disks onto the intermediate pole. So to do that, we'll go here, here, and here. And now we've successfully moved this disk to the intermediate pole. We can move this disk over to the final pole. And then now that we have this, we need to move these disks here onto the final pole. But since this is 2 disks, we need to figure out how to do that. So we simply go to the intermediate pole, we go to the final pole, and then we go from the intermediate pole back to the final pole. And that is the solution. Now this is the exact same process for 4 disks. we're just going to keep breaking down our disks and sectioning them off into sets of 2 disks until eventually we get to a point where all of the disks are on the same pole. So same thing here. Let's go back into the drawing tab. Let's pretend, what the heck is this? I did not mean to do that. Let's go to that quickly. Okay. So let's pretend that all of these disks are simply 2 disks. Okay. So we need to move all of these disks now, first of all, to here. But the thing is, these are 3 disks, right? So let's do this now. Let's say if we need to move these disks to here, let's now pretend that these are a set of 2 disks, right? So we say this disk and this disk. So we know how to move 2 disks. So let's do this now. We'll say, okay, so we need to move these 2 disks to the intermediate pole. In this case, is going to be this one. Then we need to move this bottom disk here. So we'll move that here. And then we need to move these disks back to here. We'll move this final disk back to here, and then we'll move all these disks back to this pole. Now, I know that was kind of confusing, but hopefully you're kind of getting the point here. We just keep shrinking our disks into sets of 2 disks. We move them to where they need to go, and then once they're there, we find the solution. So let's now actually create a function for this that will maybe help define what we're doing a little bit better. So let's say that's A, B, C. Let's say this is 1, 2, ... and this is N, okay? So we're going from 1 to N disks. So let's say we're gonna have a function and we'll just call it T, all right? And what this function will take as a parameter is how many disks. So in this case, we'll start with N, and then from what pole we need to go to, or what pole we're starting at to what we need to go to, and the intermediate pole. So we'll say we're going to start at pole A, we're going to go to pole C, and we're going to use pole B to accomplish that. So this is our initial kind of condition, what we need to do. So we need to move all these disks to pole C. That's what we need to do. Now, we don't know how to do that because we don't know how to move 4 disks. We only know how to move 2 disks. So let's try to break this down into a point where we get 2 disks. So what we're going to do now is we're going to say, okay, well, the first step of this problem is to move n-1 disks to the intermediate pole, in this case B. So let's write that down. Say the first step is we're going to go from T to n-1, or T n-1 from pole A to pole B using pole C. That's our first problem that we need to do. We need to move all of these over to here. And then after we do that, we need to move this disk to pole C, and then all these disks need to go back to pole C, right? So let's write that down now. And then we'll say N. So we'll say T, in this case N, goes to, actually we'll just say move N to C, okay? That's what we need to do. We just move this to here. And we know how to do that. It's just one move, very basic, all right? Now, our next step is, well, we have these 3 disks and we need to move them to pole B using pole C, but we have 3 disks. So how do we do that? So what we're going to do is we're going to break this problem down again. We're going to say, all right, well, if we need to put these disks on to pole B using pole C, then we're going to have to take these top 2 disks, so in this case, n-2 disks, and move them to pole C, move this disk to pole B, and then move all of the disks back to pole B, and then we'll have them there, right? That's what we need to do. So you can see that we're recursively trying to get down to a simpler and simpler case until eventually we get to a point where we can just move, we know how to move the disk because there's a set of 2 disks. We move them to their according place, and then we're eventually going to reach a solution. So that's kind of how that works. Now it's difficult to show this with the drawing rather than actually moving the disks. So what I'm going to do now is move the disks, and then we'll get into an actual solution. So let's do this now. Let's move all of the disks. So what we'll do is we'll say, okay, first step, we need to move these 3 disks to pole B. Well, we don't know how to move 3 disks. So what we need to do is we need to move 2 disks. So let's move these top 2 disks to pole C first of all. So we do that by doing this. Now we move this disk here to pole B. And now we need to move these ones back to pole B. So to do that, we're going to use C, and we'll do that like that. Okay, now we'll move this disk over to here. And now what we need to do is, well, we have 3 disks and they need to go to pole C using pole A. So the way that we do that, well, is we start by moving to, we're breaking this down into 2 disks now. When you say these 2 disks need to go here, we'll move that there. So what we'll do is we'll do this, 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 and continue on like this until eventually we reach the solution. And you can see how fast I'm doing this because I'm just following the kind of recursive protocol that we went through there. So now let's get into some Python code. This will be very quick to do, and we'll test our solution to make sure that it's working. So let me just put this tablet away quickly, and now we will start going. So we're going to define a function inside of our, let me actually save this here quickly. We'll just say tower.py, put it on desktop. Okay, and what I'm going to do now, define tower, and we're going to take n, we're going to take a start pole, an end pole, and a middle pole. Now our base case is, because whenever we're doing recursion, we need a base case, obviously, is if n is equal to 1, meaning we have one disk, we need to move it from a start pole to an end pole. Well, all we do is just move it from that pole to that pole. So what I'm going to do, I'm going to say if n equals 1, like this, then I will print out, in this case, we'll say move, and we'll say %i, which will be the disk number, from tower %s, like this, to tower %s, and then in this case we'll just put some brackets, we'll do %, and we'll fill in our numbers. So we're just gonna say n start end, right? Because what we're doing is, well, if we have one disk, so we're moving one disk, all we do is just move it from the start disk to the end disk, or start tower to the end tower, and that's how that works. That's all. We don't need to use the middle disk if we're just moving one. So otherwise, if we're moving more than one disk, we need to follow the procedure that we've just defined. And that procedure essentially is break it into two disks, move n-1 disks to the auxiliary pole, move that n disk, or the bottom disk, to where we need to go, and then move all of those disks that are on the auxiliary pole back to where we need to go, right? So to do that, what we're gonna do is we'll say, okay, well, let's call the tower, because tower knows how to move our disks, and we're gonna call it with n-1 disks, so splitting it up into two disks. And then we're gonna go from the start disk to the middle disk using the, using the end pole. That's what we'll do. That's our first step, okay? Then we'll say, well, after we do that, we need to move the bottommost disk to the end pole. So all we'll do there is we'll just print out this exact same statement here. We'll say, okay, so let's just take that bottom disk and move it to the pole that we need to go to. That's awesome. That's all we need to do. Now, after we do that, we need to take the disks that are on the auxiliary pole and we need to move them on top of that disk. So to do that, we're going to say all the disks from the middle pole. So because n-1 disks will be on the middle pole because we've moved them there using this. We'll say we're going to use the end, or the start disk, or no, sorry, end using start. So move from the middle disk, or the middle pole, to the end pole using the start pole. And that's all we need to do, and this is actually a complete solution to our problem. So let's define that we're going to start with, in this case, 4 poles, and then we're going to go from pole A to, in this case, we'll go to pole C, and then we'll use pole B as our intermediate pole. So now let's actually run this program and test the solution on our little game and make sure that everything is working. So in this case, I'm just going to do python tower.py. I'm on my desktop, so that's why I'm running this. And if I do this, you can see that, let's scroll down here, that it gives us a set of moves. So let me bring up now the game, and let's see if this actually works for our 4 disks. So the first move is move 1 from A to B, so let's do that. Move 2 from A to C, move 1 from B to C, move 3 from A to B, okay, move 1 from C to A, do that, move 2 from C to B, move 4, move 1 from A to B, we'll do that. It says move 4 from A to C, move 1 from B to C, okay, we'll do that, move 2 from B to A, move 1 from C to A, move 3 from B to C, okay, and then move 1 from A to B, move 2 from A to C, and move 1 from B to C, and you can see that we get our solution. So I mean, I will let you guys test this out yourself with however many ends you want. Just keep in mind that this solution, if you want to know how many actual moves, the answer to this is the moves from n-1 plus 1. So for example, we know that for 3 it takes us 7 moves. So if you want to find how many moves it would take for 4 disks, you multiply the previous amount of moves, so in this case 7, by 2 and add 1. So it's the previous amount of moves multiplied by 2 plus 1. So you have to start at some number that you know. In this case we'll start at 3, and then maybe if we wanted to find 5, well, we'd say, well, 4 has 15 moves. So what we do is we multiply that by 2, so 30, we add 1, and that's 31. And I mean, if you want proof, you can see here, if I keep going up, you can see the pattern: 31, 63, 127. That's the way that, that's the formula for how many moves. So anyways, I don't know, I'll show quickly. If I put like 100 in here and run this program, that it's going to take a decent amount of time to actually execute all of these different moves, because this is probably going to be in, I want to say like the hundreds of thousands of moves, but I mean, I don't really know. So anyways, that has been it for this video. I hope you guys enjoyed. If you did, please make sure you leave a like and subscribe, and let me know what else you'd like to see for the future of these programming problems.